talking about substitution and elimination mechanisms and the reactions that they describe for some time now. I think it's a good time for us to go back and look at all of them. It should be obvious to you by now that it's not always exactly clear which direction we're going to be going if you don't have all the details in hand. They depend on the substrate, the reagent, the solvent, and the nucleophile or base, right? The substrate and reagent are the two starting materials, right? So those four factors, if you call these two one, form an alkyl halide. Wait, 1, 2, 3. Oh, a leaving group, right? That's part of the substrate. The leaving group is part of the substrate. So these 4 or 5 factors, depending on how you count them, are different for each reaction, and we're going to consider those 5 factors as we get good at predicting the products. Okay, so it should also be clear that in many cases you're going to have more than one possible product. We've seen that a couple times. So sometimes in this reaction, you're going to get both E2 products and an SN2 product, a substitution product as well. If this is just the major product, then yeah, you can say that. But you should be aware that there are also minor products that happen. Okay, should also it's also possible for a given substrate for there to only be one possible product. Okay, so how are we going to appreciate that? Well, what we're going to do is we're going to consider all of the factors and make sort of a flow chart. In order to understand how these reactions, or how to use these reactions to transform alkyl halides into a desired compound, one must be able to predict all the products that will possibly come, including major and minor products. Okay, so here's the 3-step process we're going to use. We're first of all going to determine the function of the reagent. Okay, it's one of the starting materials, not the substrate, but that's the reagent. So we're going to determine its function. Is it a base? Is it a nucleophile? Is it either? Right? How do you spell either? Right? Okay. And then we're going to analyze the substrate. Is it primary? Is it secondary? Is it tertiary? And that's going to help us predict, right? And then we're going to also consider the relevant regio or stereochemical requirements. Things like in order to have an elimination, your hydrogen's got to be, remember this one? Your hydrogen's got to be anti-periplanar. Well, that comes down here in the leaving group leaves, right? This all has to be done in one step, and that's a regiochemical or stereochemical requirement. We'll have to consider all of those things. All right, so remember now the kinds of reagents that promote SM1, SN2, E1, and E2. And a strong nucleophile promotes nucleophilic substitution. That should be obvious, right? Nucleophilic substitution, that's nucleophilic, right? And a strong base prefers elimination. A weak nucleophile prefers SN1, a nucleophilic substitution that's unimolecular, and a weak base prefers E1. Okay, so this is something probably you should memorize. They'll make more sense to you as time goes on, but for now, I think that would be a good to memorize those. Actually, I would do a different 3x5 card for each of these. I would do a 3x5 card for that, and on the other side, I would say strong base, weak nucleophile, a 3x5 card. I would put the structure on there, okay, to help you appreciate that. The strong on the other side of the card, strong base, weak nucleophile, right? DBU, strong base, weak nucleophile. There's another one or two that we'll get in organic too, but for now, this is a good starting point. Strong base, weak nucleophile. A strong base, strong nucleophile, right? These are the only 3 that I'm asking you to appreciate right now. Weak base, strong nucleophile, right? There's 7 of them here, okay? So memorize these, and then a weak base and a weak nucleophile, and those are gonna promote those, okay? So if we've got those, let's look at this now. Once you determine what mechanism, that was the reagent, right? Let me go back. First step, consider the reagent. These are a bunch of reagents. Okay. Next step is consider the substrate. Well, a primary substrate will never go E1 or SN1. Will never, right? And a secondary, according to the small universe we're considering right now, I'm sure that there's exceptions to this, but for now we're going to say a secondary is never going to go E1 or SN1. A tertiary can go E2, SN1, SN1, or E1, right? So, and these are the reagents again, right? You can see how if you know what the reagents are, you're really set up pretty good for this. Let me go a step further and say that you'd be better off if you draw the mechanisms every time and convince yourself why these are true, okay? I've told you why in our videos, but I haven't, but surely it's overwhelming to you right now. So for you to draw out the mechanism for E2 and show yourself that a strong base and weak nucleophile is favorite. You know what I'm going to do? I'm going to add a new slide here, and I'm going to show you what I'm talking about. Let me show you what I'm talking about. I'm just going to walk you through proving to yourself one of these. I don't want to wait for this, okay? Just don't wait for that. Let's just go here, hit enter, go here, home. I'm going to show you what I mean, okay? So let's say we want to let's say we want to prove to ourselves that that is going to be exclusively E2, okay? So it's primary. So I'm going to come here, and I'm going to draw a primary alkyl halide. Okay? This is not methyl. This is the simplest primary alkyl halide, right? So it looks like it's ethyl bromide. Or bromoethane, right? So it's ethyl bromide or bromoethane. So let's go back here. We're talking about it. I just did primary, okay? Now let's take a strong base and a weak nucleophile. So here's how I'm going to do this for my eyeballs. I'm going to say a strong base and a weak nucleophile. And I'm going to put, I'm making up notes here as I go. Let me go to draw. And I'm going to say nucleophile, right? Strong base, weak nucleophile. Whatever this is, it's got a lone pair of electrons on it. Uh-oh. Oh, no. Don't, not now. Please. Okay. So a strong base and a weak nucleophile. Are you okay with me doing that? You see what I've done? If it's a strong base and a weak nucleophile, and I put a downward arrow for that, that means that, watch this. I'm going to do backside attack, and that is disfavored because it's weak. It's a weak nucleophile, right? So a strong base, though, means that it is favored. This direction is favored. Am I going there? Oops, I didn't draw my beta hydrogen. See, this is great practice. Kid you not. Let me make that a 2. Make that a hydrogen. Boom. Boom. And boom. Now, this is going to be C2, CH2. Huh, okay, there you go. That's what I've got. Now, what I did was I demonstrated to my eyes. Now, so now I'm going to ask myself, why would that not be the case? So why would it not do SN2? Well, if it's a strong base, that means the base is favored, and it's a weak nucleophile. Weak nucleophile means it's disinclined to nucleus. It's disinclined to the nucleus. This green, I crossed it off in green, right? But that's disinclined. It's not going to happen, okay? Now, I might also make it a couple notes here. I might go look back in my notes and say, what's going on here? And did I obey all my rules? And I would go, aha. Did not make substrate anti-periplanar, right? So I might do it again. If I'm studying this with someone else, I might do it again and force this thing. Here's my bromine. Then here's my my hydrogen. This then is going to have to come here, boom, here, boom, and there, boom, okay? It's going to give me the same product, and it turns out it doesn't need to be anti-periplanar because of what I've got here. But this is the simplest one I can think of, simplest thing in terms of E2. And since it shows up, since it produces something that's so symmetric, there's no regiochemical or stereochemical issues here. So I might want to put another feature on here and do it again and see, am I likely to get that if I have enough features? What's it going to take to give me this? Or what's it going to take to give me this? Or what's it going to take to give me this, right? So I'm adding one feature at a time, and I'm playing around with this. I'm chewing on it in my mind. I know that several of you are going to follow my advice and take each one of these reactions. That's just what I did right there. All I did was that one right there, and I played with it in my mind and thought, why a strong base? Why a weak nucleophile? This is much more valuable to you if you go way beyond memorization, if you churn it out, and of course, ultimately, you do want to memorize it so that you, on test day, if you're not thinking clearly, you've got to back up. Okay, so you've already got that. The first thing we're going to do, step one, is to consider the reagent. So in our previous slide, we had, strong bases and weak nucleophiles, strong base, strong nucleophile, weak base, right, and so on. The next thing we want to do is we want to consider the reagent, or the substrate. So here's our substrates, primary, secondary, and tertiary. You should draw several of these out for each of these, right? And then finally, what we want to do is we want to consider the regio and stereoisomers that can result, including the major, choose the major, if there is a major, using the guidelines you've learned. For example, SN2, you only observe a single product, which is inversion of configuration, right? And I made a big deal of that when we were drawing this. I would say, here's your leaving group. Remember, I did this on the in the previous conversation. Suppose you've got atom 1 here, atom 2, atom 3. You've got a nucleophile because it's SN2, right? That comes up here. Leaving group leaves. Everybody flips up, right? So this is atom 1, this is atom 2, and this is atom 3. It's like an umbrella. They got flipped up, where this now is your nucleophile, right? And your leaving group is gone. So what you're going to do with SN2 is you're going to get a single product, and it's going to have inversion of configuration at the alpha carbon. If two of these are the same, or three, or are all three the same, then it's not going to matter. But if these 1, 2, and 3 are all different from each other, you will see inversion of configuration, and you're going to have to allow for RS configurations. Okay. So for E2, we draw all the possible alkene isomers. And the way to do that, of course, is you first of all find all beta hydrogens that can go into the anti-periplanar position. And after you've done that, then you have all, then you've identified all possible alkenes that result. If you use a bulky base, you're going to get the Hoffman product. If you use a non-bulky base, a strong base, right, then you're going to get the most stable alkene as the major product, okay, which is the Zaitsev. All right, so for SN1, we draw the carbocation intermediate first. We draw the carbocation intermediate because the leaving group leaves on its own. Then you consider if a rearrangement is favorable. If a rearrangement is not favorable, then you just tack on the nucleophile to the carbocation, right? You should draw the mechanism out every time you do this. It'll really settle in your head better if you do. If it rearranges, you draw the resulting carbocation, and then you put the nucleophile to the carbocation there. All right, if a chiral carbon is formed by attack of the nucleophile, then you get two products. Now, I said in a previous conversation, the inversion of configuration is the more common, but they're both prevalent, right? So you have to draw both the R and S. All right, where am I here? Now for the last one, where am I? If for E1, you draw the carbocation first, and then you consider a rearrangement. If a rearrangement is possible, you draw the rearranged carbocation. After you have the carbocation, you've decided what's the most stable carbocation, then you find all the beta hydrogens, and you strip them off and make an alkene. The major product for E1 will always be the most stable alkene. All right, go practice. This is gonna settle in your head nicely. Surely in the beginning it's gonna be terrifying. Practice, practice, practice. Good luck.